equal to displacement of the body. So when a body, the displacement of the body can be obtained. Displacement of the body can be obtained by taking area of the velocity time graph. So this is a very important term. Area of the velocity time graph is the displacement of it. Once again, I speak, the area of the velocity time graph is the displacement of the body during that time interval, right? This is velocity time graph of a body which is moving the uniform velocity. The uniform velocity, with the uniform velocity, when a body moves in a straight line, then the velocity time graph will be a line parallel to the time axis. The area covered, the area of the graph, area of the velocity time graph between two time intervals, that will be equal to displacement of the body in that time interval, right? So this is what you call velocity time graph. If you draw a position time graph of a body which is moving the uniform velocity, position time time graph. Position time graph means position time graph. Position is along this is xt. X means position and the time is t. This one. If we draw a position time graph of a body which is moving uniform velocity, that will be a straight line. That will be a straight line inclined to the time axis, right? This is what is called position time graph, right? Because this is a straight line. Why? Because it travels equal intervals in equal duration, equal distances and equal position is directly proportional to x is directly proportional to t, and also it is equally increasing with equal intervals of time. That is why this is a straight line, right? The slope of the straight line of a body, slope of the graph of the body which is moving the uniform velocity is called the velocity of the body. So this is a very important thing, right? Okay. This point is x0 I can write, right? And this point is x1 I can write, and this point is x2 I can write. X1 is the position of the body when time is t1, and x2 is the position of the body when time is t2, right? We can connect this also, right? So this point is this angle can be equal to t. So this is the position time graph of a body which is moving uniform velocity. When a body moves with the uniform velocity, the position time graph will be a straight line inclined to the x-axis, right? So this case means that the body was moving from a position away from the origin. When time t is equal to 0, there was a position of the body along the x-axis. So this is the case when a body is moving. We are considering the body is moving along the x-axis, right? In the coordinate system, the body is moving along the x-axis. At any time t is equal to 0, that means when you look at the body, a moving body, first you open your eye and see that is the time t is equal to 0. That time the body was away from the origin along the x-axis. That is what is called x0. When time increases, when the time becomes equal to t1, it is along the x-axis only. That time is supposed to be equal to x1. Also, the body is again it is moving along the x-axis. When the time is t2, it is supposed to be equal to x2. Am I correct? Okay. Now velocity can be calculated. Velocity is equal to velocity. Velocity is equal. What is it? x2 minus x1 divided by t2 minus t1 we can write. So this is x2 minus x1. This much is x2. 0 to this one is x2, right? 0 to this much is x2, and 0 this much is x1. This is equal to what? x2 minus x1, right? And this is what? This point is t1. This point is t2. This is equal to t2 minus t1. Velocity is equal to x2 minus x1. Final position minus initial position divided by the total time taken. Total time taken is equal to final time minus the initial time, right? That means you are taking t1 only. When the time interval is t1 seconds, then the position of the body from the origin is equal to x1. When the time is t2, then the position of the body on the x-axis is equal to x2. Therefore, the displacement in this duration of time between t1 and t2 is x2 minus x1. Time taken is t2 minus t1. So this is velocity. Am I correct? So this can be written as equal to simply dx. This can be written as equal to dx also. The small displacement, of the body for a time t2 minus t1 can be given as equal to t2 minus t1 can be given as equal to dt also. Right? Therefore, velocity is equal to dx by dt. Velocity is equal to dx by dt. The rate of change of position of the body is called its velocity. Rate of change of position of the body is called its velocity. So what is dx? Dx is perpendicular. What is dt? That is the perpendicular base. That is equal to tan theta. That is equal to tan theta. When I taught you differentiation, I told you that differentiation can be used for rate of change. Right? Rate of change of position of a body with the time is called velocity. When a body moves with the uniform velocity, the displacement, the position time graph will be a straight line inclined to the time axis. Then slope tan theta is called a slope, or differential coefficient is also called as slope. Slope of the straight line is equal to tan theta. Tan theta is equal to dx by dt. So differential coefficient is slope. Why slope? Because slope is equal to tan theta. What is tan theta? Tan theta is equal to velocity. Slope of the straight line. What straight line? Dt. What is called a position time graph. Slope of the position time graph of a body which is moving the uniform velocity is its velocity itself. So from the position time graph of a body which is moving uniform velocity, we can calculate its velocity. How we can calculate velocity? By finding the slope of that straight line. So this is what is called uniform velocity motion. All these things done, right? So tomorrow we will come with another topic, right? Till then, bye bye. Thank you very much.